So in the last video, I think we have discussed up to copy the reversed list. How you can able to copy the reversed list. Now I want to copy the original list. I want to implement a program to copy the content of same list as it is, that is original list copy I want to take. Yeah, very good evening. Right. Now, if you take this element, I want to write a function called copy list. I want to implement a method called a copy list, which should copy the same list again. Okay. Anyway, that copy list method is not there. So I'm taking single linked list, copy list as the method name. Okay. So now you have to write a big code here. Okay. So for that, first I will write the code, then I will explain. Node, I'm going to take a head node is equal to null. Okay. So I'm going to take one more node called tail. Tail node is also null. And you required one temporary node. So temporary node is also null. Okay. Next, I'm taking current node. Current node, we know very well, it is always pointing to the head. Like this, I'm taking some special nodes. Okay. Now, observe carefully. So, if current node is equal to null, that means if there is no head node, then we have to return null as usual, because original list we are going to take. Otherwise, so I'm going to take a head node is equal to, I'm creating a new head node, sir, which will become node of, so current node dot data comma null. Like this, I'm going to create a new head node. Sir, already head node pointed by current node, so there is no problem. So old list you can point by using current node, new list you can point by using this head node. Okay, that's why I have declared two pointers. And directly first I will write the instructions, sir, then I will explain the code. So tail node will become head node, tail node will become head node, then your current node will become current node dot next. Okay, current node will become current node tends to next. Sir, while your current node is not equal to null, so here I am going to write temp node will become new node of, so current node dot data comma next field is null. Okay, so after this, tail node dot next field will become your temp node, then tail node is equal to, we have temp node, then so current node will become current node dot next, single linked list obj is equal to new single linked list, then obj dot as usual head will become head node. That's all. Like this we have to take. Anyway, I will explain how it is going to work internally. Have a look once. Sir, here consider I am going to take a node like this, something like this is nothing but the first element, and this one will become the second node, it will become third node, this is null, and this node is nothing but what, a head node. Like this I need to create a copy of this. Initially head node is null, tail node is null, temporary node will become null, current node will become head. Head node is different from head, so current node is equal to head. This one will become, so current node, this one will become current node. Okay, then is current node is equal to null? No. Then I'm going to create one new node. What is the name of that node? Head node. So head node where current node data is 1, So next field is null. Like this we are creating. Then tail node will become head node. So this will become tail node also. This will become tail node also. So current node is equal to current node tends to next. That means this link will be gone. From now onwards, this will become current node. Okay. Now observe carefully. While current node is not equal to null, is it null? No. Then temp node is equal to new node. I am creating a new temporary node. Okay. This will become temp node. Okay. Tail node and temp node. Let me take this one as a temp. So what is the data here? Current node data. Current is this one. It's a data and the next field is null. Now tail node is there, right? Tail node next field is pointing to this particular temp node. So that by default, this will be gone. Okay. Next tail node will become temp node. This will become tail node. Okay. Now current node will become current node tends to next. That means this will be gone. Now it will become current. Again, is it equal to null? No. Then one more node we are creating. What is that node name? So temp node. So what is the data? Whatever current node data is there, that one. And the next field. So tail node next field is temp. This is the tail node. Next field will become this temp. So that this link will be gone. Now tail node will become temp. So that this will be gone. Next current node will become current node tends to next. Next, is current node is not equal to null? No, it is not equal. So temp is equal to new node. We are creating one more node that will become temp. Okay. So its data is nothing but a current node data. Next field is null. Tail node next field is temp. Tail node next field is nothing but a temp node. Okay. So that this link will be gone. Sir, now what we are giving? Tail node will become this one. So that this link will be gone. Okay. Now current node is equal to current node tends to next. Now it will become null. So again, while loop is current node is not equal to null. No, current node is null. So it will come out from this while loop. We are creating a new single linked list object that head is pointing to head node. This will become head node. So that we got this entire list. Okay. Like this, it is going to work. So I think you people got a clarity about this one. Can you please confirm? Is it clear now? Everyone? So how you can able to create a copy of the list? Is it clear for you people, friends? Please confirm everyone. Is it clear? Now, I need to execute this code, sir. Okay. So what we have to do? Just we can execute. Already we have copied that list. Let's open our command prompt. So Java C, I'm taking test.java. Code compiles fine. Java space test. You can see we are getting a list like this. Okay. 1, 2, 3, like this we are getting. And this one also we are getting like this. Okay. So I hope you people got very clear clarity about this. Okay. Sir, now everyone, sir, please respond. Is it clear? The copying of the elements. Please confirm. Yes. Now I want to compare two list objects. Sir, consider I have list 1 is equal to, I want to take some list, something like a list 1 dot. So add last of, I am taking 111. So list 1 dot add last of, I am taking 222. List 1 dot add list, sorry, add last of, so 333. Like this, I have one list is there. So I want to print list 1 dot print list. It is going to print first list. In the same style, I want to create one more list, which is nothing but 2. Now I need to check one method, sir. What is that method is? So list 1 Okay, list one dot compare list one. So here I am taking another list called list two. So it has to return either true or false. True means both the list objects are having same content. False means those two are not equal. That means comparison. So for that I am taking boolean. So compare list one. Yeah, order is same elements. Number of elements should be same. Content is also same. If the data is not in order, so you have to insert according to the order and then we have to do. Okay. Right. Only for equality I'm comparing. So here I'm taking single linked list, one list object I'm taking. Listen carefully. Already we are working on one list object. Since we are used list one dot. So list two will be copied to this list. Already we are working on single list. Now node I am taking head one will become head. Okay. So head two I am taking list dot head node because sir on the current node on the current working object we have head. So that is nothing but list one. List two argument we have passed. That head value I am taking. So two head objects are there. Now you have to check a look. While was your head one is not equal to null. Okay. And your head two is not equal to null. That means both objects are existed. Then check whether head one dot data is not equal to so head two dot data. That means head one data and head two data both I am checking. If it is not equal, what is the need to stay in that? Simply return false. Okay. Sir, otherwise, what we can able to do? So head one will become, so head one dot next. So that means what? If this condition is not satisfied means what? Both are same. So if the first element is same, we are moving to the next element. Sir, we are not moving head pointer. We are moving head one, head two. Remember this. Like this we have checked. Sir, again we have to repeat the loop. Same thing. That's all. So if your head one is equal to null and head two is equal to null after completion of this while loop, if both are null, that means what? Same elements are there. Otherwise we have to return false. Anyway, I will execute this code and I will show you. So there are multiple cases are there in this. I will draw all the cases. Sir, first case, consider, so I don't have any list. Means what? Sir, my head one, okay, my first linked list, that is nothing but list one. So is nothing but this one where I don't have anything. Head pointer is pointing to null. List two, I have like this where head pointer is pointing to null. So this is the first case. So I am taking one list object. Head one is equal to head, that is nothing but null. This will become head one. This will become head two. Head one is not equal to null. It is null. Head two is not equal to null. Null. It will come out from while loop. Is head one is equal to null? Yes. Head two is equal to null? Yes. That means both are same. Means what? Both are empty list only. Now in the first list, so I have head is there which is pointing to null, and the second list is there head to head, so which is having only one item. Okay, this one will become head 2 now. Sir, head 1 is equal to head, head 2 is equal to list dot head. Sir, head 1 is not equal to null. No, it is not. It is null. So it will come out from this. Is head 1 is equal to null? Yes. Is head 2 is equal to null? No. That means it will return false. These two are not the same. These two are not the same because one element is there here. This is another case. Now third case, very, very important. Consider my list. First list is nothing but we have elements like this. Only two elements I am taking for convenient purpose. This one will become head. My second list is having two elements. 1 and then 2. Like this we have. This one is nothing but null. So this is a head node and this is null. Sir, head 1 is equal to head. This one will become h1. So head 2 will become list2 dot head. Sir, head 1 not equal to null. Yes, it is not equal to null. Head 2 is also not equal to null. Is head 1 data is not equal to head 2 data? No, head 1 data, head 2 data, both are same. It will come out from this if head 1 is equal to head 1 tends to next. It will become head 1. Sir, head 2 is equal to head 2 tends to next. This one will become head 2. If head 1 is equal to null, is head 1 is equal, so it will come out from this, it will execute while loop one more time. Is head 1 not equal to null? Yes, it is not equal to null. Head 2 is also not equal to null. Data is same, right? Yes. Then head 1 is pointing to null. And head 2 is also pointing to null. Then is head 1 is not equal to null? No, it is null. It will come out from this. Is head 1 is equal to null? Yes. Head 2 is equal to null? Yes. Then true is the answer. Like this we have. You can verify this with the remaining cases. They're clear up to this. Please confirm everyone how this list comparison is going to be happened. Is it clear for you people? Right. I want to execute this. I want to execute this. Let me execute my first list and the second list. Both are same. Sir, in this place I am taking 444. Now is it same? No. False. Okay, like this we are getting. Sir, I want to implement a recursive method for this. Okay, I want to implement a recursive method for this. So I will take list2, compare list2. So which is also a recursive method. Recursive method means you know very well. So recursively it is going to perform comparison operation. Let us see how it is going to be executed. Okay. So here list2 I am taking. Okay, which is going to take a list, and I don't want to take this entire thing. It is going to call some other function because we have to do compare list. Okay, so where I'm going to pass head node and then list dot head, two nodes I'm passing. Okay, because directly we can't call, sir. That is the reason. Okay, because it is having only one argument. But if you want to compare, you require two arguments. That's why manually I'm calling. Somewhere also we have done like that. Do you remember? Somewhere, yes, reverse. So here we have used a separate function for that purpose. Okay. Now, sir, now we have to implement Boolean. Which method we have to take? Compare list, which is going to take two nodes. Node, same formula I am using. Head 1. So node head 2. Like these two nodes I am taking. Listen carefully. So if head 1 is equal to null and so head 2 is equal to null, then what we have to do? Return true. Okay, else if again I am checking. So if head 1 is equal to null or so head 2 is equal to null. Okay, this is one condition. Or head 1 head 2 is equal to null. So or one more condition. What is that condition? Okay, so if head 1 dot data is not equal to head 2 dot data, so first one is null or second one is null or data is not equal. So in such a cases, what is the meaning? Those are not equal. Okay, otherwise what is happening? Definitely it is equal. Else what we have to do? We have to make a recursive call. Again I am taking compare list. What are the arguments? Head 1 next field, here head 2 next field, because we are comparing for next two elements. That's all, very simple. Now listen carefully. I will take one example and explain this. For example, consider I have 1 and this field is nothing but 2 and this field is nothing but 3. Okay, so null. Here we have head. Now one more list I have 1 and here I have 2. Listen carefully. So here I have 3. Okay, so here I have 4. Definitely I'm expecting answer as a false. Now see how it is going to be compared. Head is equal, this one is nothing but head 1. This one is nothing but head. Is head 1 is equal to null? No. Head 2 is equal to null? No. Then head 1 null? No. Head 2 null? No. Head 1 data not equal to head 2 data? No. Both are equal. So return compare list. Head 1 next. This will become head 1. And head 2 next. This will become head 2. Now his head 1 is equal to null? No. Head 2 is equal to null? No. So any one is null? No. Data is same? Data is not same? No. Then again head 1 tends to next. This one will become head 1. This one will become head 2. Okay. Now you can able to check. Is both are null? No. Any one is null? No. Data is not same? No. Data is same. Again compare list. So this one will become head 1. So this one will become head 2. It is null. Okay. Now you can able to see. Sir, what output we are getting? Is head 1 is equal to null? Yes. So is head 1 is equal to null? Yes. Head 2? No. That means this condition never satisfied because we are using and. Is head 1 is equal to null? Yes. So if any one condition is satisfied, no need to evaluate, simply false because those two are not equal. Suppose consider, sir, here this node is not there. Then your head 2 is also will become null. Then head 1 is equal to null and head 2 is equal to null. Return 2. This is the base condition. Okay. So I think you people got a clarity how recursively it is going to work. And I think so. So you got very clear clarity that recursion is more powerful when compared with the normal implementations, right? Will you agree this? Can you please confirm clear up to this whatever I have covered? Clear, friends? Please confirm everyone. Is the concept is clear for everyone? Okay, right. So the next one, okay, let me execute this. What output I am expecting? Both will be same, false, false. If both are having triple two, then so we are going to get a true. Perfect. Sir, comparison, both cases I cover. Excellent. Now my question is, sir, I want to take, okay, I want to take finding nth node from the beginning and ending. Okay, I want to find out nth node from beginning and ending. So I will take only list one. So I will add a few more objects. Okay. 444, 555, 666, 777, 888 like this. I want to search for a node. So for example, consider system.out.println of list1 dot nth node from begin, like this I am taking. I will provide the index, for example third node from the beginning. I want to find out, sir, anyway it is going to return an object. What kind of data is there in linked list? Integer. That's why, so I am taking a return type as integer. Now observe carefully, friends. If whatever index that you have passed, if it is greater than size, okay, or whatever index value you have passed, if it is less than 1, okay, that means I am going to return -1, which indicates that there is no element like that. Otherwise I am taking count is equal to 0 as usual, sir. You know tracing, right? So I am going to take current node is equal to head, while your current node is not equal to null, and so current node, no, so count value is less than index -1 till that. So you have to increment the count value at the same time. So current node will become current node dot next. You have to, after coming out from this, just we have to return current node data. That's all, very simple. Let us see how it is going to work. Okay. Consider one simple example. Consider this is nothing but a first node. So this is nothing but another node, this is nothing but another node, this is nothing but another node, something like this we have, and next field is null. So this is a head node, right? I want a second node from the beginning. I want a second node from the beginning. Okay, sir, index value is nothing but a second. Is index value is greater than size? 4 elements are there. Is 2 is greater than 4? No. Is 2 is less than 1? No. That means count will become 0. Current node is nothing but this one. This is current node. Current node not equal to null. Yes. Count value. What is a count value? 0. Is it less than index minus 1? 2 minus 1? 1. Condition true. Then count plus plus. Count will become 1. Current node will become current node tends to next. This will become current node. Current node is not equal to null. Count is less than index minus 1. 2 minus 1. That is nothing but 1. Condition is false. It will come out from this loop. Current node data 2 is the output. Second node from first 2. Okay, so nth node from the beginning, if you pass 2, second node from the beginning is nothing but 2. Okay, like this we are going to get. So let us run this code. Really it is working. So I want a third node from the beginning. First node, second node, third node. Sir, I want sixth node from the beginning. Sir, first node, second node, third node, fourth node, fifth node, sixth node. Like this I am getting. Okay, so if you provide 19th node from this, then what option we are going to get? -1. So if I'm giving 0th node from the beginning, 0 value is there? No. So first node from the beginning, you will get that 111 only. Sir, clear up to this? Please confirm everyone. Right. Sir, I want to check nth node from end, sir. Nth node from end. Sir, I am using same algorithm in reverse. So integer, I am calculating size is equal to get size. What is the size of this linked list? So integer, I want to calculate a starting index. Starting index. If whatever size is not equal to 0 and the size is less than index value, less than index value means we have to return -1, saying element is not there. Is your starting index will become total size minus index plus 1, right? Total size minus index plus 1. Now you can call another function nth node from the beginning by passing s index. Very simple. Sir, what is this? Very simple. Sir, listen carefully. This is my first node. This is next node. This is next node. This is next node. This is next node. And this is last node. This is head. So they are asking last second node. Last second node. That means this answer we are expecting. See what happens. Because we don't have any pointer here. We have pointer only at the beginning. So size is equal to, what is the size? Size of the linked list? Size is equal to 0 means it will, 1 second, we will check. 1 second, please wait. Listen first. So size is equal to, how many elements are there here? 1, 2, 3, 4, 5 elements are there. So your size will become 5. Size is not equal to 0. Okay, size is not equal to 0. Yes, it is not equal to 0. Okay, sir, size is less than index. So is that 5 is less than, what is the index value? 2. No. So it won't return -1. Size is not equal to 0. For example, if you don't have any elements, okay, but you are trying to access some 7th location like that from last 2 like that, then I think this one will come. Okay, so anyway, we will cross check. Then starting index is equal to size. What is the size that you have given? 5. 5 is the size. Minus which index you want? Second index. Plus 1. Sir, 5 minus 2 will become 3. 3 plus 1 will become 4. So from last 2 nodes means that is a 4. From the beginning fourth node, 1, 2, 3, 4. Same, right? That's all. Sir, if size is less than index, suppose consider I want to extract from the last seventh node. Last seventh node. Sir, what about the size? Your size will become 5. So size is not equal to 0. Yes, it is not equal to 0. And your size value 5 is less than index, that is 7. So in such a case, it is going to return -1. Okay, like that we have. Clear? Sir, I think no need to explain about this function. You know very well. Right? Can you please confirm, is the concept is clear for you people? Now, sir, I will execute this code and I will cross check really whether it is working. Nth node from the beginning. I will take sir, third node from the beginning, third node from the ending. So third node from the beginning. So 1, 2, 3, third node. Third node from the ending. So 1, 2, 3. Correct, right? So this is nothing but how you can able to work, sir. So with this, successfully we finished linked list concept. Okay, clear, right? Up to this, any doubts, friends? So I think except that reverse with recursion, everything is finished. So I will explain that reverse with recursion. I didn't practice that. I will take a tree diagram and I will explain for you people. Okay, right, sir. So that's all about today's session. Remaining things we will continue tomorrow. Tomorrow, as usual, we have class at 7:15. Okay, and the spring class. Yes, Sagar, correct. So this weekend we have spring class, sir. Saturday. So 7th January 2023. So we have spring class is there. So the class starts from 7 p.m. Okay, the class starts at 7 p.m. as usual, 7 or 7:15 p.m. as usual, our regular class link. So use regular class link. So I will take minimum 2.5 hours time, sir. Okay, 2 to 2.5 hours. So 7 to 8 or 8:30 like that I will take, or sometimes 9 also. Please prepare up to 9. 2 hours I will take. Okay, right, sir. So thank you. We will meet for the continuation tomorrow. Thank you.